Alright, so in this example video we're going to work with charging capacitors. So we have an uncharged capacitor that has a capacitance of 30 nanofarads and is placed in series with a resistor of 50 ohms and an EMF of 20 volts. And we need to know what the current will be through the circuit when the capacitor is 63.2% charged. And we also want to know, does that correspond to the current being 63.2% of its maximum value? So we first need to figure out the time at which Q is equal to 63.2% of its max value. So we want to find out when Q is equal to 0.632 times QF. So for Q, I have plugged in 0.632 times QF, and then I've canceled out the QF on both sides. We're left with 0.632 is equal to what it was in parentheses of the original equation. I'm then going to do some algebraic rearrangement so that I can solve for t. So first I'm going to subtract 1 from both sides and then multiply by -1. So that's how we get the 0.368 here. And then I'm going to do the natural log of both sides to get rid of the exponential. I'm finally going to plug in the resistance in the capacitance and get a time that is 1.5 times 10 to the -6 seconds. Now you could have skipped this whole step because remember 63.2% is when t is equal to the time constant. So I could have established what this time was by simply taking the resistance times the capacitance, because that is equal to the time constant. So if you took R times C, you would get this number anyways. Alright, so now I'm going to go to my current equation and plug in the time, and that I get the current is 0.147 amps. Now, in order to establish what percentage of the current we're at, or the maximum current, I'm going to sub in for I, little I, for our current equation, X times the max current, and for the EMF or the resistance, I'm subbing in the max current, so that the max current cancels out on both sides. And remember, the 63.2% is equal to the time when t is equal to tau. So I plugged in R times C here, which is the same thing as the 1.5 times 10 to the -6 seconds. And the RC over the RC cancel each other out, so I'm left with the exponential raised to the -1, which gives me 0.368. So this is exactly what I expected, because as we discussed in the lecture portion, as the charge increases, the current should decrease. So you could expect that when we're at 63.2%, the current is going to be at 100 minus the 63.2%, which is exactly what we got here.